This is a video to help people in the future, someone in the future, if they get the opportunity to rebuild a 1938 Voisin sleeve valve engine, they'll have a little bit of an idea how to go about doing it. And I want to briefly include some information that I left out of the video. One is regarding the junk rings. It's very important that the junk ring fit very tightly in the cylinder head. And by that I mean up and down, the width of the junk ring needs to be within 1/1000th of play in the cylinder head. The inner sleeve will pull up and down on this junk ring, and if that junk ring isn't very tight in the cylinder head, then it'll make a clicking sound. It'll wear the head out, and it'll make an unacceptable noise in the engine as well. And the end gap on that junk ring should be about 0.04 per inch of diameter. So in this engine, that was about a 0.12 end gap, which was the same as the piston rings. Another aspect of the engine that I want to put out here is the valve timing, or the sleeve timing. On this particular engine, the exhaust closed at 8.5 degrees after top dead center, and the intake valve opened at 10.5 degrees after top dead center. So there's a 2 degree difference between the exhaust closing and the intake opening. You can't get any valve lap on the engine. It runs great, so I'm satisfied with the cam timing. It's different than any of the information I was able to get from any of the other sources. Another aspect is when you go to remove the crankshaft from the engine, it will require a good deal of pressure to push the main bearing out of the case. I had to use a long brass drift and a hammer, and it was really, a bit alarming to have to do that kind of pounding on something, but after a number of years of sitting, that's what it's going to take. And a couple things, an outfit that did all of my centrifugal babbiting, that's what's necessary on the main bearings, was Fusion Babbiting, and they're out of Milwaukee, Wisconsin. They did a really great job. And then my chrome plating was done by US Chrome in Rochester, New York, and they did a really great job too. Saved a great deal of money by plating these sleeves. So what I want to do now is show you the sleeves for this Voisin sleeve valve engine. It's a 1938 Voisin. So this is the inner sleeve, and this inner sleeve fits into this outer sleeve, and both sleeves travel about 3/4 of an inch up and down, just closing the ports that are cut on either side. Now, the clearances between these two sleeves and then the outer sleeve to the cylinder block, which is behind me, is about 2 to 3 thousandths. Now, this engine, when we got it, these sleeves were really out of round, and the gap between the sleeves was about 8 thousandths, and a little more in some cases. So there's a fella in France, Philip Mouch, M-O-C-H, and he apparently is the expert on Voisins, and he was going to be able to make us a new set of sleeves, 12 sleeves in all, for 27,000 pounds, which at the time would have been about $32,000 to $35,000. So there was the issue of distance and language barrier and time frames And the fact that this is a museum piece is not going to be taken out on the highway at 60 miles an hour. So I decided to pursue different options. And the one I came up with was to have the sleeves hard chrome plated. And this is a method that is used to restore cylinders on motorcycles and other vehicles. And I found an outfit in New York, a U.S. Chrome, and a fellow by the name of Mike, can't think of his last name right now. They were a little reluctant at first to take on the job, but they agreed, and they did a fabulous job. They took and ground true the outside of the sleeve, and then they plated it, and then they ground it again to get the 2/1000 clearance between the inner sleeve, the inside of the outer sleeve, and the outside of the inner sleeve. And then they ground the outside sleeves to the dimension that I requested, so that then I could have the outer, the cylinder block bored, or honed in this case, to accept the sleeve. So what this does is it means that you don't necessarily have to replace the pistons. In this case, our pistons were fine. If you needed to and you had excessive wear, though, I could have plated the inside of the sleeve, and therefore not had to purchase new pistons. So all of the expense in plating and resizing the sleeves saved me a great deal of expense in machine work to the cylinder block or to buying new pistons, etc. So the cost for this intensive machine work and plating, and you can see perhaps the shiny line that indicates the thickness of the chrome plating, and some sleeves, I think it was as much as 10/1000. This cost about $7,000. So I think I've been able to do all the necessary machine work and parts for bearings, surfaces, etc. for less than what it would have taken me just to replace the sleeves. So we'll find out if it works. My only reluctance, only fear is that on the exhaust side of the sleeve that's subject to a great deal of exhaust temperature heat, I might end up getting some delamination of or flaking of the plating. I don't think that's going to happen, but that's the only risk I think that I have. In any case, this is the cylinder head, and each cylinder has its own cylinder head. And this ring that I'm moving here that is secured by this orange nye tie, this is called the junk ring. And this junk ring fits, and this cylinder head fits inside the inner sleeve. And this is what seals the inner sleeve to allow combustion. So this inner sleeve travels up and down, maybe 3/4 of an inch at most, on this junk ring. And the lubrication that you get on the sleeves and on this junk ring is all splash. On the junk ring, I'm certain that the only lubrication taking place is just the carbon from the ignition that's taking place. There's just simply no other way that any lubrication would get up around here. As far as the sleeves go, all of that lubrication on between the sleeves and the cylinder block is all just splash. There's no pressurized lubrication system. And so it does cause me a little bit concerned since the clearances are so tight. It's been stated that sleeve valve engines smoke. Well, I'm sure that today they do smoke, because I'm sure most of the people that do these reconstructions probably have a greater clearance between the sleeves because they don't want them to seize up, and they're willing to put up with a little smoking rather than run the risk of having them seize up. I'm pretty certain that, given the engineering I've seen on this engine, that these engines probably did not smoke much at all over their tappet engine counterparts. The clearances are really tight, and this particular Voisin was a very high-end car, and I can't imagine people wanting to put up with a cloud of smoke trailing behind them when the comparably priced cars wouldn't have been doing that. In any case, what you have to do when you do the assembly on this engine, you have to take the inner sleeve, because the rod, let me get my rod, the rod is too large to go into the inner sleeve. So this means you cannot put the sleeves in the cylinder block and then attach your piston and send it down to the crankshaft. No. What I have to do is take the piston, put the rings on it, put the piston into the inner sleeve, and then attach the rod to it, and then slide the inner sleeve into the outer sleeve. And so I have this type of arrangement for installation. Now, you see I have the rod in the inner sleeve and the inner sleeve in this, and now you see hanging down from the sleeves are the connecting rods. These connecting rods are full circle. There is no cap, and this, of course, was very interesting discovery as well. And I'll try to show you how these connecting rods to the sleeves go on the camshaft. It's a very interesting camshaft and a very interesting method of construction. But this is what you have to have in order to insert into the cylinder block in order to then start your assembly. So what I'm going to do now is I've got my sleeves and piston rod and sleeve connecting rods assembled, and I'm going to now put them, after I get this puck out of here. There. I'm going to put these into the cylinder block, which is the black piece of metal over there on the floor. I want to point out that the piston rod has this notch in it right here. And this is got to go on the same side as the sleeve connecting rods. And also the piston skirt that has the cut in it for the stress relief, that also goes on the same side. All of these are facing on the torque side of the engine. On this engine, it is a clockwise rotation engine. Some of the sleeve valve engines that were made by Daimler are counter rotating. So the one concern I have is as I have these sleeves in and as I'm connecting the sleeve connecting rods to the camshaft pucks, I do not want to inadvertently knock the rod down and have the piston rings come out through the ports here in the sleeve. That would be kind of a bummer. I'd have to drag trying to get it back in again. So what I've done is I've made up these blocks that are 3 1/8 inches tall, and I'm putting them in the cylinder so that when I slide this in, I can be sure that my piston is not going to go down and pop out. There's still a certain risk because the cams, once these sleeves are attached to the cam will go up and down, causing the sleeve to go up, which if I'm not careful I could still end up pushing the piston down too far. But this is the best safety measure I could come up with. It's possible that that they used originally that they installed the sleeves and then they put the pistons and such in later, but you'd still have the same problem. You know, you could still push the piston down too far. I don't know, maybe they had some special tool that they put in to keep that from happening. But in any case, I haven't been able to figure out any other alternative, so I'm going to try it like this. So I'm going to go ahead and put in all my sleeves and rods, put my aluminum case. After I do that, I'll put my aluminum case on. I'll put this camera on my head to see if I can show you how that's going to take place. Anyway. Now, as you can see, I've got all of my sleeves, my pistons, rods connecting, sleeve connecting rods all in place. I'm holding up my rods in with pieces of paper towel, and I've got my sealing gasket on with a little bit of sealer on it. Oiled everything up, and now I'm going to take the case, and this case is really incredible. The crankshaft has to come out through the front of the engine, and you can see the machine work and casting work that was done. This was in 1938. The camshaft, if you can see it, goes right in through this area here. So in any case, I'm going to lift this on and put it in place. There we go. Yes, it looks like it's down. I'll pull my tissues out. Now comes the part where I will take the camshaft here and take these pucks that make up the lobes of the camshaft, and I will feed the camshaft through here and feed each puck onto a spline on the shaft. As you can see here, there's a number 1 on this shaft spline here, and it's repeated over here, number 1 again. And the numbers on the pucks coincide with where this groove is. See, this number 1 goes in the spline that's marked number 1. All of the pucks have numbers on them where they are supposed to line up on this same number 1 spline. For instance, this is a number 1, cylinder 1. This puck over here is cylinder 1, the number 2. The number 2 still goes on the same number 1 spline. They all line up on this same spline. And then you've got your spacers that you have to include as well. And this is going to be probably the trickiest part of the whole engine assembly. So, okay. So, what I've done to this point is I've put the camshaft, spline camshaft, I've slid it through, and you can see in here, I hope, the the connecting rods for the sleeves. This is a connecting rod. This is a connecting rod for the inner sleeve, and this is a connecting rod for the outer sleeve. So I slid it through and put each puck on, lined it up on the properly marked spline, and fed each one through. Tedious job. It's the hardest, probably the most difficult job of the whole process. But you can see how these, the flat part on this rod here where my finger is, why that's cut out. And it's to clear this area here on the cam when this is all bolted up to the crankshaft. So what I've done then, after sliding the camshaft, the spline camshaft through and getting all these sleeves to work, now I will be putting on the cam gear, and I'll show you the nut. This nut is left thread, and it drives a small water pump, circulating pump. And this these holes line up with this hole here in the camshaft. You turn this on, and I mark the hole. I've already pre-assembled this. I mark this hole, and when this lines up, I'll slide the cotter pin in, and then I will tighten it all up with the nut in the back, right in here. A nut that has a cotter key in it goes in place over here. And that pulls the whole assembly tight, locks everything in. And that's what I'm going to do. And after that, then I will attempt to slide the crankshaft in and see if we could get that installed. Okay. So, what I've just done here, and it's a two-man job, and I've got Russ, my expert machinist, helping me with this. The trick is, on the crankshaft, to have the two center journals in the up position, and then you feed it through. It'll only go through a certain way. You see how the crankshaft is got this angle, and that matches the casting. So it has to go through in one angle, one flow. And we're going to stop it right here so that I can put this center bearing on. That's the two half bearings that I have here. And we'll have to fit these on and bolt them together, and then tap the crankshaft in the rest of the way. So, okay. One problem that we had that I want to try to go over with the viewers. Okay, we've got our crankshaft in, and in order to slide the crankshaft in, we had to rotate it so that the number 3 and the number 4 crank journals were up. And then we were able to slide it right in, and then put the center main bearing on, and then finish sliding it in. The other problem that we had is it's got an oil baffle right here, a plate. And this plate is particularly difficult to get out, and just as difficult to get in. But the trick to getting this front baffle plate in is to rotate the crank so that the flat journal here, the flat counterweight here, is parallel, and then slide this piece in from the top going down. You have to use a little screwdriver or bar to slide it down, because these bolts will hit along this ridge here. And once you slide that in, then you can put it in position with the spacer that goes here, and then we'll be able to put our front main bearing on. You cannot put the front main bearing on until this plate is in here. And these baffle plates that they have in here, and they have two that we haven't put in yet around the main bearing, are to control the oil, to force the oil from to contain it in the area where the sleeves are. So we're going to, those are about the most critical parts. We pulled all of our rods up and connected our rods, and no rings were stuck in any sleeves. So far everything's going pretty well. One other helpful hint that I really should put on here, I imagine anybody doing this might see it before I did, but I'll do what I can to help you out. The bolts that go in to this housing come in from the back and need to be placed in to these holes prior to this baffle being installed. You can see how difficult it is to get this in place. But these bolts need to be put in while everything is loose. You're never going to get them in once things get fastened down. And there are 1, 2, 3, 4 bolts that have to be put in before you put this main bearing in, the front main bearing, and then attach this plate to it. Okay, a couple of other points I wanted to make sure we're clear. I had to take the cam gear off in order to clear, for the crankshaft to clear this area. The cam gear interfered with this area. And now that this baffle's located like this, there's a screw with a shim on it, a spacer on it. And this is what secures it at the bottom. You see the hole right there. I don't know if you can see it. There's a hole right there. And this screw and this shim. And so we put wax on the on this shim here so that it won't fall out. And this does not have any gasket on it. I've greased my main bearing, and this goes in place like this. And I'm going to put this screw, start this screw on this plate first. So I've got the crankshaft in, and all the rods have been torqued, all the pins are keyed in. I got the main bearing, front main bearing in place, keyed in. And the rear main is in and the flywheel's on. The main bearing has been secured, located with a center nut and bolt. And now I'm going to have to install these baffle plates here. And these baffles go in down in here. You can see, maybe you can't see. And let's see, how do we get this out? There it is. Okay, you can see how the baffle plates are in. They're numbered. And this again is to keep, I assume, is to keep oil up close to the sleeves as possible, because it's all just splash. And you secure these with bolts, and there are 6 of them. And then after those, then I will put in these plates. And these plates go down like this, and they go on either side of the main bearing, the center main. And I really have no clue what these are for. No idea whatsoever. I'm at a loss. Anyway, they were there. Oh, I guess it would be to help in case anything got loose, which this is a nice tight fit and it's located with this. But I guess maybe it would keep the main bearing from working its way out, which would be pretty hard to do since I've got a 4/1000 clearance on my thrust here, meaning the whole crankshaft is located, the end play is located off of that main bearing. So, got it on the engine stand. Got it. Okay. I've got the sleeves in place, pistons in place. As you can see, timing gears are in. And here's my head gasket. And I put a light coat of silicone sealant on it, very light. And I'm going to place this on after thoroughly having cleaned everything. I'm going to seat this, and then I'm going to take the cylinder head. This is the cylinder head, this is the junk ring. There's a pin right here, and this junk ring has to collapse on that pin. And I'll put the junk ring in the cylinder, bolt it all down. Oil it up really well. Put a light coat of sealer, just because of all the pitting that's taken place over the years. The corrosion, that's the only reason I'm putting this added precaution of sealer on it. Okay, so the engine's together. I'm going to start it up, and you'll see that that it doesn't smoke, not burning any oil. The carburation on it is a little bit oversized, so you get a little black smoke when you go to accelerate. That may be normal. Not much I can do about it right now. So let's see, I'll start it right up here. Let's see. Okay, that smoke is vapor from that cold temperature coming in. There wasn't any smoke before then. So there it is. Running about 50, 60 pounds of pressure.